My topic is extracting discourse atoms or just atoms in a TshiVenda corpus. I'll start by giving an introduction, which gives an overview of the project and the data set that is being used in this study. There is a need for diverse and inclusive data sets in developing good NLP solutions, and unfortunately for African languages, there's a lack of good curated data sets. And TshiVenda, being one of the least spoken languages in South Africa, really just extends that problem as well for this particular language. Appropriated vast amounts of data are a prerequisite in developing these good NLP solutions to understand what documents and sentences are about. And the key concepts of discourse analysis are topics, and these are defined as what sentences or documents are about and their focus. So in this study, we then explore and exploit word embeddings or monolingual word embeddings for the TshiVenda language, and we do this through training a word embedding and using dictionary learning techniques for the sparse representation of the extracted atoms. This research holds significant implication for promoting linguistic diversity and inclusivity. The data set that is used in this study comes from a monthly newsletter by the South African government called Vuk'uzenzele. This data set was curated and standardized by the Data Science for Social Impact Research Group at the University of Pretoria. The cleaned and standardized data set contains a maximum of 4,121 sentences. The methodology that was used, or approach that was used in this study, was adopted from the referenced literature with some tweaks here and there. We train a monolingual embeddings on the TshiVenda corpus using various techniques, word2vec on GenSim, and other approaches were explored as well. We then try to model these topics or these word embeddings on a semantic space using a dictionary learning algorithm called KSVD, which outputs a set of K vectors. And this then allows us to represent these vectors as a linear combination, or these topics as a linear combination of atom vectors. After that, we then map the observed sequence of words back to the semantic space and vice versa. The picture on the right represents the step-by-step process that is followed or explored. And various algorithms were also explored in dictionary learning and the decomposition, and also other clustering algorithms were also explored after performing dictionary learning. These include K-means clustering, DB-scan, and it was also evident in other literatures that this approach is relevant. The BERT topic model was developed using an approach which is a little bit similar but more advanced as compared to what was used in this study. And then some of the results that we obtained for the two models, or word2vec or word embeddings model that we developed, we looked for similar words that represent a polisa, which basically means police officers. And for the skip-gram model, the most similar words were public servants, which is Washimerababo. And for the fast text model, we got a polisani or polisa. Then we also evaluated this model using coherence, topic diversity, and other metrics, and the results are presented as below. The results obtained, they are positive, and we hope to improve on these results. And then we also presented some of the extracted topics on the left-hand side there. And then we went further to then explore the different discourse atoms and the vectors that represent all the relevant or extracted discourse atoms. The contextual meaning of these vectors, some of them or most of them they do share a similar meaning or a similar topic of discourse. And we believe that with a larger data set, these results can be improved and other techniques will be explored to improve the results. The coherence metric of our models decreases with the number of components topics that were considered, and this is shown in the graph that is on the right hand side, which shows the coherence co-similarity of the top 25 topics modeled on the components topics. Then, in conclusion, this study explored word embeddings using dictionary learning and modeling topics as a sequence of atoms, and this allowed us to draw out information about the TshiVenda corpus. We believe that unstructured text data can hide patterns or information that can reveal interesting pieces of information. And various studies have shown this as well. We hope to further our study by transforming documents or a corpus into a sequence of atoms, and also exploring the presentation or understand the sequence of atoms and how gender and other protected variables are related to certain topics in a corpus in African languages. And I thank you.